This is the first in a series of basic supply chain modeling using Logix. We'll cover setting up your first supply chain model, entering your data, viewing your model, and optimizing a simple supply chain network. Let's start by looking at how to set up your data using Logix. You'll usually use Excel, comma-separated variable CSV files to import your data into Logix. In this very simple model, we'll start with just customer demand. And the templates and formats in the Logix data conversion that come with the model show you how we've set up this very simple model using demand represented by population under this column here, quantity A, for each of the states in the United States. So we really only have 48 demand points in this very simple model. Again, a very small model as well. Each of the demand points are centered in various cities throughout the country. And here's a basic format, including the quantity, basic count, how many shipments this quantity represented, and how many square feet or cubic feet were represented by this quantity. Again, we use very simple numbers, 6,437,193 represented 6,437 square feet and 64 shipments. Now again, in this very simple model, we're only going to use demand data. So we're going to kick off a Logix session by simply using a new project in this case, and we'll import our data. In this case, we'll start with how to add customers from our demo data. And again, here we're just representing exactly what we just saw, all the demand for each of our states and the population represented by the 2010 census in this case. We have 48 customer stops and no distribution centers, no cross docks, no suppliers. We also only have a default record here with some parameters, but our ship unit, our basic ship unit, is 100 pounds. So we're using hundredweight here. And our transportation cost, very simple, $0.0075 per mile per hundredweight. There's no fixed cost, just a variable per mile. Our demand points are shown here in the show listing, which you're always able to access by simply clicking this icon here. All of the icons are available if you press home, and subsets of those icons are available under each one of these major headings. So if we have project, we can open a project, create a new project, save a project, print out that project data, save our work, show the data, as well as other features, mapping, for instance. Editing, we can add a site, delete a site, save a site, many other options there as well. Under data, we can import our data, which we've already done in this particular case. We can view maps. We can access various reports. So all of these capabilities are available from the pull-down menu, as well as many of them are available with these icons. So let's first take a look at our view of the supply chain modeler, which we had seen earlier with 48 customers, but here we're just taking a look at the demand points as well. Logix uses Google Maps for all of its map functionality. You can also use MapPoint. So here you see all of our demand points represented here. from this data. Well, let's close this now and take a look at some basic parameters. You're always able to click on Display Parameters or go to Modeling Parameters to see what options you have turned on. Here we'll click on Quantity as a primary measure, but you can click on Size or Count. Now our size is square feet, so you can put in square feet. Our count is number of shipments. We're going to take a look at detailed data. And we want to display distance instead of time in this case. And there are a lot of parameters that we can turn on and off, whether in network optimization or a transportation optimizer, rates and distances, and geocoding. But right now, we'll just leave the model like this to run a very basic model. Once we have all of our data, we can choose the number of sites we want to optimize. Now, in this particular model, we have no distribution centers, either existing or candidates to work from. So what we want to do is to turn on greenfield optimization. So we've turned on our greenfield option, which allows us to model and select distribution centers in greenfield mode. In other words, we don't have to have any candidates available to us at all. And if we want to set the number of sites at 1 and use the supply chain network optimization, again, if we choose solve here, that is the first option, we can optimize for one distribution center that will serve our entire set of data here. So Bloomington, Indiana, approximately 92 miles south of Lafayette, Indiana, is the optimal location to serve all of these sites at the lowest cost, and that cost is $24,416,715. It's made up of transportation costs, of warehouse costs, and product costs, where warehouse costs could be fixed cost for the single facility, as well as per square foot costs, variable per square foot costs associated with the square feet that are required for this distribution center. We can also view our supply chain modeler and maps of this solution with the site here centered in Bloomington, Indiana. Now, one of the things that Logix does is it will select the exact location by city. It'll tell you how far it is from any point in your data. Lafayette, Indiana happens to be one of our data points in our data, so it knows we know where it is. Bloomington, Indiana, it pulls from its geocoding data, and that's the closest it can come to the exact optimal location. Exact optimal location is 39.0921 degrees of latitude and minus 86.986 degrees of longitude. But typically, you're not going to remember latitude and longitude, but it knows that you probably know where Lafayette is, and it's going to tell you the optimum is in Bloomington, Indiana. Now, our unique proximity radar view, we can turn on here by simply clicking here. In fact, let's take the scale down to 400 miles across here. And here we'll see that the optimum isn't just that one point in Bloomington, but actually extends about 100 miles west, 100 miles south of Bloomington. We can also click on maps here, and we can get a similar representation here on our maps. These little red and green dots representing the location here of Bloomington. And you can see here, you can go 100 miles in those directions and still have about the same cost before our costs go up. And in fact, our costs go up much more rapidly as we move north than if we move either west, east, or south. And very helpful in terms of locating facilities optimally. The optimum doesn't have to be in a particular one single point, but can actually be in a geographic area. Let's turn this off. And now we'll try to optimize 2 sites. And those 2 sites are San Francisco, California, Carlisle, Kentucky, just outside of Louisville, Kentucky. And again, here we'll take a look at our modeler maps. And as you can see here, the 2 site optimums for this problem are located here and serving these customer areas. And again, if you wanted to click on proximity radar, again, you can see here that Carlisle, Kentucky lies outside of Louisville, Kentucky. And again, pretty flat here, but you wouldn't want to go in any other direction other than east. Otherwise, your costs could escalate pretty rapidly. We'll refresh again. And you see here that the optimum really isn't Louisville, Kentucky. It is Carlisle, Kentucky, and the cost can go down just a little bit. Now, what if we wanted to know how many distribution centers and their location instead of telling Logix how many to pick from? You can leave this blank. We'll put an asterisk there. And again, here we're solving for the location and the number of facilities that optimize this problem. Now, greenfield optimization shows us that the number of sites to optimally serve the entire country is 4, in this case at $14 million. Takes about a little over 2 minutes to solve this problem. And it shows us the assignment of customers to each of the distribution centers, where they're located. This one is located 25 miles south of St. Louis, Missouri. This one a little bit outside of New York City and Akron, Pennsylvania. Again, the other site in San Francisco, and one in Miami, Florida. That would serve South Carolina and Florida. Again, we can take a look at the maps. Use a representation. We can even, if we want to, put in our one-day service area, which might be about 600 miles, for instance. Refresh our maps. And it shows us here what the 600-mile radius for each one of these locations is. So you can imagine this is probably about as far as you could go in terms of service within one day. And these will probably service in 2 days. On analytics, and click here, and we can see that our one-day service, about 79% of our customers can be served in 1 day, 21% can be served in 1 to 2 days. Nothing over 2 days. You can also take a look at charts here, and metrics which show us total cost, each of the facilities, and their quantity and total cost, cost per unit, cost per square foot for each of the facilities, the size of each facility, service metrics, what the average weighted distance is for each one of them, average time to serve customers in each one of these areas, and the capacity utilization for each one of the facilities. These are just some of the metrics that are available to you. In the end here, you can always view summary data, which shows you each one of the sites, the quantity, the size of the facility, the outbound cost, warehouse product cost, and the total cost. There is no inbound. We have no suppliers in this case. And you can save this so you can take a look at it at any time. Detail model results show you all the details that we were just taking a look at, including all of the customers that are served by each of the facilities. And again, you can save that solution as well. And lastly, you can export the model solution for this particular distribution model so that you can manipulate it in Excel or any other report writer that you choose. So this is how we've set up a very basic model. In the next video tutorial, we'll take a look at how to add distribution centers, either existing or candidate facilities, and we'll solve a very basic model using our distribution centers.